In today's lesson, we are going to be looking at graphing quadratics from a table of values. So this is our first lesson in our quadratics unit, and while most of the content is going to be some review from last year, we're just going to start off with the basics, just graphing a quadratic and looking for some characteristics. So if I'm given an equation like we see here, y equals x squared, that is a form of a quadratic equation. If I want to graph from a table of values, I need to figure out what my y values are going to be based off of this equation and the given x values. So what we're going to do is, I'll just do one example, or at least one kind of full method. We're going to go through and we are going to just replace the x with whatever the x value is in our table. So -3 squared, which equals 9. I'm going to do that for every value. So then -2 squared will be 4. Then we have 1, 0, 1, 4, and 9. So now I have enough information to go through and graph my quadratic because the x and the y values form a point. Right? So for example, the first one, -3, 9, that's an ordered pair, that's a coordinate. So I go over to -3 and then up to 9 and put a point. -2 and 4. -1 and 1. 0, 0. And then it does repeat on the other side. So we do have a symmetrical looking graph, and then I'm going to just kind of connect those points to form a curve. So that's what my quadratic looks like. There are some other pieces of information in the table though, or other columns that we do need to fill out. So what the first one, or what the first differences are asking us to do, is basically subtract the second y value from the first one. So in this case, we're going to do 4 minus 9, which equals -5. Or in other words, we're seeing what do the values change by. So 4 minus 9, or from 9 to 4, that's a change or a decrease of 5. From 4 to 1, or 1 minus 4, that is a decrease of 3, or -3. 1 to 0 is -1, 0 to 1 is 1, 1 to 4 is 3, 4 to 9 is 5. I can do the same thing, or that's our first differences. And we should notice that none of the numbers are the same. And when we look at the next column, we're doing the second differences, we're going to be doing the exact same thing, except with the first difference values. So we're going to do -3 minus -5. We're going to see what the change is from one value to another. In this case, we're increasing, or +2. From -1, or -1, minus -3, that becomes +2, or it's an increase of 2. From -1 to 1 is also an increase of 2. From 1 to 3 is an increase of 2. And from 3 to 5 is an increase of 2. And what we should notice here is that all our second differences are the same. So all of our second differences are the same. And that is going to be a characteristic of a quadratic. And you should have I believe you should have looked at that already in grade 10. Now, last couple things to look at for our quadratic. Looking at our quadratic, what direction does it open? And when we talk about the direction of the opening, or how it opens, we're looking for where the open part of our graph is, or of our parabola. And we see that the open part here is at the top, so that means our parabola opens up. The vertex is the lowest or the highest point, or you could say it's where it changes direction. And in this case, the vertex is right here. So this vertex has the coordinates 0, 0. So it has a vertex of 0, 0. And when we talk about the steps, right, you may have looked at the steps or the step pattern in grade 10, but when we zoom in, just because it'd be easier to see what the steps are. So we start at 0, 0. We start at this point here. And what the steps are when I move left or right 1 unit and then go up to my graph, how big of a step up is that? So if I go over 1 or 1 unit, right, not necessarily 1 square, I go over 1 and I go up until I hit my graph, that was an increase of 1. I do the same thing, I go over 1 again and go up until I hit my graph. Again, we have to keep in mind, go to the point, right? If you're drawing, hopefully you drew a little bit more accurately than I did. But my next point was an increase of 3. because I went from 1 to 4, so that's an increase of 3. Do the same thing, I go over 1 again, and I go up until I hit my graph. And this is an increase of 5, because I went from a height of 4 to a height of 9. So these values right here, the 1, 3, and the 5, those are our steps. So the steps are going to be 1, 3, 5. And those are the characteristics of our vertex, or some of the characteristics. Let's look at another example. So here we have a slightly different equation, x squared minus 2, or y equals x squared minus 2. So all that changes is when I plug in a value, be y equals negative 3 squared minus 2, or this becomes 9 minus 2, or 7. If I do the same thing, negative 2 squared is 4, minus 2 is 2. Negative 1 squared is 1, minus 2 is negative 1. It's negative 2, negative 1, 2, and 7. And depending on how our graph is, we should see a repetition of values, right? When you think back to a quadratic, that parabola, if you think back to grade 10, that U shape, there should be kind of a repeat of Y values. If I want to go through and look at the first differences, right? From 7 to 2, what is that a change of? Well, I can do 2 minus 7 and I get negative 5. So that's a decrease of 5. For the next one, negative 1 minus 2, that's a decrease or negative 3. I then have from negative 1 to negative 2, that's a decrease of 1. This is an increase of 1, an increase of 3, and an increase of 5. So looking at my first differences, they are not the same. I want to check my second differences. So from negative 5 to 3, or negative 3 minus negative 5, right, we see that is a increase, so positive 2. From negative 3 to negative 1, or we do negative 1 minus negative 3, that is an increase of 2. We see it's also an increase of 2 for every other value. And again, our first or second differences are the same. That is what we're looking for, right, in a quadratic. I can plot my values. I'm going to plot my ordered pairs, my coordinates. So negative 3, and 7, negative 2 and 2, negative 1 and negative 1, 0 and negative 2, and then it repeats on the other side. It is symmetrical. And I can connect my points, and again I see that U or N shape. In this case, again, for the opening, again I look at where the open part of my graph is. It is at the top, so that means that this quadratic opens up. Looking for the vertex, where is the vertex, or where is the lowest or the highest point? Here is my lowest point, so the lowest point is 0, negative 2. And the steps. So again, I'm going to go to my vertex. I'm going to go one direction, left or right. This time I'm going to go left just to show you it does do the same thing. So I go to my left 1 unit based on the scale, and I go up, and however many I have to go up or down, depending, is going to be my first step. So in this case, the first step is 1. I then go over 1 again, and then go up until I hit my graph, or go to the next, go up till I hit my point, and I see that this is an increase of 1, 2, 3. So my second step is 3, and then again from this point, go over 1 up until we hit our graph, or the next point, and this would be an increase of 5. So again, the steps are 1, 3, and 5. And if you were to go to the right, I'll do an example in this one. If you were to go to the right, you would get the same thing. So if I go to the right 1 and up, that's an increase of 1. Go to the right 1, increase up, that's an increase of 3. Go to the right 1, and oh, it looks like I didn't draw a point accurately. So it should be right here. So let me just fix that. So sometimes following the step pattern will be helpful because that will be able to tell you whether you've plotted the right points or not. That's an increase of 5. So we see either on the left or the right side, it's still the same step pattern. It's still increasing by the same amount from one point to the next on both sides, because again, this is a parabola and quadratic, and we should see a repetition or similar values on both sides. Now there are 2 more examples with different types. So take a second, create your table of values, find your first and second differences, determine how the parabola is opening, what the vertex is, and what the steps are. And we'll come back and take a look and review what we should have. So if we come back to see, what we should see, and we should have our table here, we should see again the first differences are different, the second differences are the same, and when we graph it, we should see something like this. Now, you're only going to see the blue points based off of the table of values, but for me, understanding what the next points are going to be, I can mirror it on the other side, because what that's doing is it's giving us a vertex of 3, 0, and then it's going to be the same values going up on the other side. In this case, the parabola does open up. Our vertex is different. It's no longer 0, 0. It's now at 3, 0. And the steps are still going to be 1, 3, and 5. Right? We start at our vertex. We go left or right. We go left 1 in this case, just based off the values that we actually do have. We go left 1 and up until we hit our graph for the next point. It's 1. Go left 1 again, go up until you hit your graph, that's 3, and then go left 1 again, and you go up until you hit your graph, or 5. So it's the 1, 3, 5 again. With the next one, again, plugging the x values into the equation to get the y values, finding the difference in the y values for your first differences, and then finding the differences between the first differences for your second differences. You should find that your second differences are the same. They're all -4. When we plot it, we can only plot some of the points. We can only plot from -2 to 2. But that does give us enough to plot it. In this case, the parabola does open down because we can see the opening is now at the bottom. So this is opening down. It still has a vertex of 0, 0, and the steps are -2, -6, -10. So that means we start at the vertex, go left or right. In this case, now we have to go down to our next point. So we go left or right 1, and then we go down 2. So the first step is -2. From that point, we go right 1 again, and we go down until we hit our graph, which is down 6. So our second step is -6. I put -10 in there just, again, I know what the pattern is. And that's kind of what we're going to look at now. So for the equation, y equals ax minus h squared plus k. If you remember a bit from grade 10, this was what we called our vertex form. And we'll look at that a little bit more in depth before, but all those values do have important characteristics, or they tell us important things about our graph. But for right now, we just want to focus on the step pattern. Now, the steps or the step pattern are a general pattern, and they all have the a variable, which comes from the equation. So the step pattern follows a pattern of 1a, 3a, 5a, 7a, 9a, 11a, and so on, but we really only worry about the first three steps. So 1a, 3a, 5a. So what that means is whatever the a value is in our equation, we multiply it by 1, and that's our first step. We then take that same a value, multiply it by 3, that's our next step. Multiply 5 by our a value, that's our next step. And that helps us that can help us graph our quadratics or determine what the a value is from the quadratics. So if we had an equation where a was equal to 4, so that could be something like y equals 4x plus 3 squared, something like that as an example. My step pattern would be following the general pattern, 1a, 3a, 5a. You could do 7a and so on if you wanted to, but you don't need to. That means it's going to be, 1 times 4, because a is our 4, or a value is 4, 3 times 4, and 5 times 4. So then this would be, my steps would be 4, 12, and 20. So those would be my steps, or the step pattern for this any quadratic with an a value of 4. Now we would need more information to help us graph it, but if we had a vertex, then we can use that step pattern to find our other values. Right. Main thing though from this is just kind of recognizing some characteristics, kind of getting back into the habit of looking at quadratics and parabolas, understanding that when the second differences are all the same, it's quadratic. And then how can we determine if it's opening up or down, where the vertex is, and how can we find the steps when we have the graph of a parabola.